Alright, so today we get to actually start programming in Java. What we're going to do is take a look at what Java is, what type of programming language it is, and how it works, and then we'll start creating some actual programs. So, what is Java? Well, Java is an object-oriented programming language. All programs that we create in Java are built around objects. Essentially, any program is a whole set of objects that work together to make the program function. Let's take a look at the example of Call of Duty. In Call of Duty, you've got a world filled with objects. You've got all sorts of people around you. Each person has guns or a variety of guns and grenades. Each gun has a whole bunch of bullets in it. So the program itself is those people objects running around, shooting their gun objects. When the gun object is fired, it fires off a bullet object. The bullet object travels through the air, hits another person object, and causes damage. So all these objects are working together to make a full program. Why would we use Java? Well, there's a number of reasons. The first reason is that Java's free. Basically, you can download Java for free at java.sun.com. You can also download environments to help you write the Java program language for free online. Things like NetBeans, Eclipse, Dr. Java, and so on. Secondly, Java's platform independent at both the development level and the runtime level. What this means is that you can write your programs in any environment. So you could write it in Mac, you could write it on a PC, you could write it on a Linux system, and then once you've written that code in one of those systems, you can then run it on any other system. So you could write a program in Mac and then run it on a PC. Thirdly, Java can be run in most current web browsers, which is obviously convenient. And then finally, Java is a relatively simple programming language, so it's easy to teach you right off the hop. When we work with Java, there are two major types of program groupings. The first one is the one we'll focus on in this class. It's called an application. An application program is basically like any program you normally run on your computer. It's meant to be run with a command line interpreter, which means it runs out of MS-DOS, or the CMD prompt window. In order to do this, all of the files must exist locally on your computer. And if you want to have a graphical user interface, the program must contain code to create that window within it. And if you want to run a program as an application, you also have to have access to some form of standard input, like the keyboard, and standard output, like the monitor. The other type is an applet. An applet is a Java program that's embedded as part of a web page. So instead of having the files stored locally on your computer, the files are actually stored within the web page itself. And you don't need to have code to create the drawing surface for your GUI because that's conveniently provided for you on the web page as well. What we're going to be doing is we'll be creating applications. And to do so, we have to have three pieces of software. The first is called an Integrated Development Environment, or IDE for short. This is a program that we use to actually write the Java code. Now, it could be something as simple as Notepad, but usually you want something with a little more features that can help you in your code. So you might have something like NetBeans or Eclipse, and in our class we'll be using a program called Dr. Java. The second program you need is a compiler. This program converts the code that you write in your IDE into bytecode that the computer can understand, essentially a whole set of zeros and ones. This compiler program is conveniently performed in Dr. Java itself, so we don't have to download anything separate for this. The third program is a Java Virtual Machine, or JVM. This program takes the bytecode that you've created with your compiler and converts it back into a machine code that an individual computer can run. So you take that bytecode that you've created on a Mac or on a PC, and then you take it over to any other program and run it on the Java Virtual Machine to run it on the computer. So in order to create a functional program in Java, you have to do the following steps. First, you have to write the code in a Java file, a .java file. This is called the source code. Once it's been compiled, it becomes a binary file or bytecode stored as a .class file. This .class file is the one that you'll run, and it can be run using the JVM. And here it is in graphical format. So again, you can see you've got your source code that you've written out in Dr. Java. You've compiled it to form bytecode, which is a set of zeros and ones, and then that bytecode can then be implemented in any machine that you want, using its own specific JVM for that type of machine. So how do we actually go about creating an application? Well, an application in Java requires two major sections, the class and the main method. The class is basically the word we use to describe the entire program. All of the code within a particular program is going to be stored within a class. And inside that class, we're going to have a number of methods. The main method is going to be the code that's run when the program is first started. And as I said, it's located inside the class. So what might this look like? Well, here's an example of a very simple program that essentially does nothing other than print the word "Hello World" to the screen. The outside portion in red here is called the class. You can see it says public class. The name of the program is Hello World. Everything that's included in the class is enclosed in squiggly brackets. So you see one at the beginning and one at the end, and you notice that they line up vertically with each other. The main method is the part in between the class. So it's the part in red here. Okay? Every main method has to be called public static void main string args. Don't worry about what this means right now. Just know that it needs to be there and that it means that this is the code that's going to run when I run my program. And again, just like the class, I've got a squiggly open and a squiggly close showing the beginning and the ending of the main method. So this whole program boils down to one line of code that is essentially going to print out the words "Hello World." So I'll switch over to Dr. Java here so you can see this program. So there's exactly the same code I was just showing you. And I can compile the code. And it says down here at the bottom that I've completed my compilation and it's no errors. And then I can run it. And it runs an output to the system down here where it says "Hello World." Now, that's a little bit ugly. So we want to make our output look a little bit nicer. To do this, we're going to use a library, which is essentially a set of code coded by somebody else that we can import into our program. And the library we're going to be using was created by people who made another IDE called Ready to Program. Okay? This library is called the HSA library, and we need to import it into Dr. Java. To do this, what you're going to need to do is go over to Edit, Preferences, add an extra class path, and then find the lib file. This file is going to be located in my outbox on the For Teachers folder, and you're going to need to copy it into your G drive. So once it's in your G drive, you'll select it, hit apply, and OK. Now it's been loaded up into the Dr. Java system so we can include that code in our programs. The specific code we need within that library is called the console class. And a console is going to make essentially a very nice, pretty window for all of our output to appear. To do this, you're going to have to import the code into your program. So while the library is known to Dr. Java, these lines of code are going to import specific pieces of code from that library. Once that code's been imported, you're going to have to create the console within your program so that you can print to it. That's done doing 2 lines of code. So static console C, this says I'm going to make a console, which I'm going to name C. Now you can use anything you want to name your console. You can call it the Mr. Burns console if you really want to. C is just shorter and simpler. Once you've named your console, you then have to create a new console. So C equals a new console. So that'll look something like this. Import hsa.console. Capitalization is important here. Import java.awt.star. And then within my class, because this is part of my program, I'm going to want to make or declare a console. And then with my main method, I'm going to want to make my console exist. New console. So now instead of printing to my system down here in the bottom, this ugly little spot down here, I'm going to print to my console. So if I compile this and then run it, you'll see this nice little console that now prints Hello World. Looks a little bit prettier. So, how do we output text? Well, there are a number of commands we can do to output in general. But to display text, we have to use 2 methods called the print and printline method. So a method is essentially a command we're going to provide. The print method is used if I want to remain on the same line after output. So if I was to do print output here, my cursor would remain on the same line for the next time I want to print. If I do print ln or print line, it's going to be basically the same idea as hitting return after printing. So if I printed this word output as a print line statement, my cursor would now go underneath, ready for my next print below. Here's an example of what this looks like. So I've got c.print15, c.print12. You'll notice that this outputs all of it in one line, one after the other, versus the print line methods, which print a 15, go to the next line, and print a 12. Another thing I can do is I can print equality equations. So I could say print 7 greater than 2. Since that is true, it'll print true. If I said print 2 is greater than 7, well, we know that's not true, so it would print the word false. Now, in order to make my output look nice and pretty and easy to read for the user, which is very important to making professional looking programs, you can do that using a number of different methods. The first is essentially by hard coding it. Means putting it specifically into your code. So if I was going to have something I want to print here as a mark and have a nice space between the colon and the number, I can put the space here in my actual sentence that I want to print. So here's a mark, colon, space, close quote. Then when I print the next part of it, it won't be mashed right up against the colon. I could also write the previous code in a single line like this. Here is a mark plus 86. What this plus sign means is I'm going to convert this number into a word, which we call a string in Java, and attach this word to the sentence that was there before. Now, you need to be careful when you do this when you're working with numbers, based on whether you're putting the number before or after a sentence. You can see down below here an example. If I print 2 plus 3 plus is 5, it's actually going to do the math here and go 2 plus 3 is 5 and go 5 is 5. Whereas if I put the numbers after my sentence, it assumes that I'm using these as words instead of numbers, so the plus becomes a symbol to join those two strings together. So now it becomes 5 is 2, 3. If I use a multiplication symbol instead of an addition symbol, it says, well, multiplication can only be done using math, so it's going to perform the math. So this becomes now 3 plus 3, since it's before the string, it's 6, is 3 times 2, 6. So we get 6 is 6. An alternative way to control the format of your output is to use something called a control character in the output statement. So in this example here, I've put two control characters. I've put \n and \t. The \n control character is a short form for saying pressing the return button or hitting enter. The \t is a short form for saying I want to hit tab. So this code here, all in one line, would output hello there, enter, or \n, tab, or \t, and then my name is Bob. Here are a number of the commonly used control characters. So you can see the \n and \t. We've got double and single quotes, which allow me to put quotations in my actual output. Because if you look back before, the quotation at the beginning and the end shows me where my sentence is going to begin and end. So if I want to actually output the quote, if I just had a quote there, it would say, well, that's the end of my quote. It's not actually going to get printed. So I have to say, oh, I actually want to print an actual quote. If I want to print a backslash, I have to do two backslashes. So I know that I want a special character backslash of the backslash. Otherwise, it assumes that this backslash is representing one of these control characters. So to print a backslash, I need to have two separate backslashes. The final way we'll look at doing formatting of our output is to use something called a format item. A format item is going to tell me the size of the field I want my output to display in. So how many spaces do I want to store my letters in? If I have a number, it's going to be right justified in that spacing, and if I have a word, it's going to be left justified in that spacing. So let's look at an example. In this case, I want to print 3 numbers. The first time I want 6 characters of space, the second time 3 characters of space, and the third time 3 characters of space. So if I print 35 with 6 characters of space, I have 1 space, 2 space, 3 space, 4 space, 5 space, 6. There are 6 spaces, and I'm going to right justify it. Now these underscores won't actually appear, they're just here to help show you the spacing that would exist. So assume that they're just blank spaces. Because I used a print, right after it I'm going to have the next thing. In 3 spaces, I'm going to have the number 12, right justified. And then in 3 spaces again, I'm going to have the number 2, right justified. If I want to do a decimal number is called a double. I can do that and display as many as 16 digits to the right of the decimal place. Any trailing zeros, so like 3.1000000, those trailing zeros will be omitted or not included. So for example here, 5 divided by 16 is 0.3125. If I want to show this in 12 places, you can see I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'm right justifying it in 12 spaces, and remember that the decimal counts as one of the characters in that spacing field. If I have a repeated number, so something that's going to repeat indefinitely, like 5 divided by 3, which would be 1.66666666, I can add a second format item, which tells me the number of decimal places to include. So I'm going to show this 5 divided by 3 in 6 spaces with only 2 decimal places. So again, 1, 2, 3, 4, 5, 6 decimal places, 1.67 showing 2 decimal places. Extremely large and extremely small values are output in exponent form or scientific notation. So 13 million, instead of being 13,000,000,000,000, it's going to be 1.3 times 10 to the exponent 7, right? Or E7. And as I said before, string values are left justified and can also be formatted to look like this. So the word balance in 10 spaces, followed by the word interest in 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the word balance left justified. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The word interest left justified. So this will allow me to do things like putting words into columns if I wanted to do so. Alright, so now we can start creating some of our own programs.